But on number 2, where you had the square root, there was some people that had some questions about that, it looks like, and also on number 3 as well. So let's take a look at number 2 and number 3, so you can kind of see what we need to do there. So remember, when you're finding the domain, usually it's going to be all real numbers, except for 2 different cases, right? In one case, if there's a fraction, right? So except with fractions, right, the number that makes the bottom 0, or I'll put numbers because later on we'll be talking about there will be more than one number that will make the bottom 0. So number or numbers that make denominator 0, right? We can't do that because we can't divide by 0, and so that's why that one. And the other exception, so fractions and then also square roots. You can't have a negative inside the square root. Okay, so when I'm looking at number 2 on the quiz, when it's asking you to find the domain of this function, f of x equals the square root, and notice that the x minus 2, right, is all inside that square root. Okay, so that means something different than if you had the square root of x and then minus 2. Right, so watch closely on these square roots whether everything's included inside or not. Okay, so I'll just get rid of that over there because I don't need that for this one. But so when you're trying to find the domain of this, you're going to put what is inside the square root and put it greater than or equal to 0, because remember, any number that's bigger than 0 is a positive number, right? And then and it can be equal to it also, so it could be 0 or bigger, right, to be a non-negative answer. So then when we add the 2 over, we get x is greater than or equal to 2. And so that's saying everything bigger or equal to 2. So if we were thinking, you know, just of a number line, what that would look like, it would be 2 and then everything to the right. Okay, but to write that in interval notation, we'd have the bracket 2 to infinity. Now remember that you always need to write your interval notation from smallest to biggest. So sometimes people switch these two things around and think that it is, you know, that it is infinity to 2, but, you know, and when they really mean 2 to infinity. So just make sure you're watching that kind of closely, that you're writing your things from smallest to biggest. Okay. And then on number 3, this one, and we're going to talk more about this kind of today when we're, you know, give a little bit more notes and stuff about it. So we're trying to solve, graph, and write our answer in interval notation, and it gives us 2 different inequalities that we're going to be doing here. And notice that the word that connects them is and. Okay, and so we're going to talk about the difference between and or statements today. And then 5x plus 2 is greater than 17. All right, so we have these 2 inequality statements, and so you're just going to solve them each separately, and then we'll come back and talk about what this and means. And hopefully that when you watch the video, as you were able to get, you know, kind of an understanding about what that means. But when I solve this, I get x is greater than 1 on this side. And then I'm going to solve this one also. Let's see, so 5x is greater than 15, so x is greater than 3. And so when I'm drawing this out, let me try and put this on a graph to help you see. So I know I'm going to be dealing with 1 and 3, right? And so this is a number line, and so that I need to kind of make sure that I'm writing it as such, right? Smallest to biggest on here. So both of these, they don't have the equal to part on them. Remember, they don't have like greater than or equal to. They're just greater than. So that means they're going to be open circles. So let me do these in a little bit of different color. So I'll have an open circle at 1, and I want all the stuff that's bigger than that. So that's going to be all the stuff going to the right. And then my other one is going to be an open circle, and all the stuff greater than 3 is going to be all the stuff to the right again. Okay, and this and statement means that you want the overlap. You want to know what they have in common. Right? So those are kind of the ways to think about it when we're talking about and. So notice that between 1 and 3, there is no overlap of these two graphs, right? But starting, right, but not including 3, but from 3 and bigger, that's where our overlap is. And so when I write my interval notation for that, I'll have open circle, right? And then from 3 to positive infinity. So that's the parts that overlap, but it doesn't include the 3 because that's an open circle. So the overlap really doesn't start, right, until after our circle there. Okay. What questions can I help clarify there? Hopefully that was helpful to see some of those. All right, well yeah, I know, and it's really easy to write something down, like you have the right answer and then you write down, you know, something wrong, and on these it is really important, or just mark the wrong answer on there, maybe not noticing if it had the square bracket or the rounded bracket and stuff like that. So just make sure you pay close attention to those things, because I know it just sucks if you do it correctly and then you just select the wrong number, especially on a test or something like that. So, but most of the test questions, I'm not sure that all of them, but I know most of them are going to be like the short answer, you know, where it's not going to be multiple choice. But there could be a couple of multiple choice if they're doing some graphing or something. But yeah, I'll give you more information though. I'll ask and find out about that for sure. All right, let's do a little bit of notes for 3.1, and I hope the things that I say in here will help clarify things that you had questions on in 3.1, but also make sure that you're finding any questions, you know, that you have also besides the things that I go through here. So 3.1, I'm talking about solving inequalities, but also you talk about applications, right? Some story problems with inequalities. So first off, I want to start off talking about, you know, because in our applications, there's going to be words, and these words, you know, there's going to be certain phrases like fewer than, or more than, or at maximum, or minimum. And so we need to make sure that we understand which inequalities those kind of go along with. All right. So let me see here. Do a couple different colors here. So if you see this, right, symbol, then that's going to correspond with phrases like fewer than or less than. Right? If you see something like this, usually that corresponds with just something like more than. And sometimes you'll see a statement that says like must exceed. Right? So like if somebody's, talking about, trying to figure out how much they want to get paid, and they're saying, I want my salary to exceed $65,000 a year or something like that. All right? That's just the greater than symbol. Doesn't have the equal part on there. Okay? But what about something like these? So if I have this symbol, this less than or equal to, right, that could correspond with the phrases at most, right? So at most meaning it could be that number or smaller, but not any bigger than that, right? It could correspond with maximum. So here, we're trying to find the maximum. No more than, is another phrase you might hear, or cannot exceed. So it could be that number, but it can't be bigger than that number. Right? So, sorry, cannot exceed. So yeah, so it has to be less than, completely less than that number. Sorry. All right. Let's look at the other direction now. So what about ones like this? All right, so this one, sometimes I'll say at least, right? And then minimum, or no less than. Okay, and then there's another one that I want to talk about. And that is, sometimes you'll see an inequality where there is a variable between two numbers, right? So if you see something like this, and I'll just make up some numbers that kind of go along with it. If you have 40 is less than x, which is less than 50, right? When you see, in a story problem, it would say something like, what you're trying to find is between. Right? And then you might see something with the less than or equal to. Right? So if it has the equal to part, then it will say something like, is included and between. So sometimes they'll say between and inclusive of 40 and 50, right? So they have to say specifically that it includes those numbers. If it just says it's between and doesn't specifically state that it includes them, then leave off the equal to part. Okay? All right, so hopefully just understanding, I know math is a foreign language, and some people, kind of jokingly say that, like, oh, it seems like such a foreign language for me, but it really is. Like, there's a lot of translating that you have to do in math and understand these words, right, that we see in applications in these story problems mean something specific. All right, hopefully that was helpful to be able to have those written down so that you can, see these a little bit easier. Everybody have those written down. Scroll at least to here, maybe if you're still trying to get the rest of that. I don't want to move those too quick for you. All right, but let's talk about just solving inequalities. Let's do one example where we're just going to be solving an inequality. And this one is, has a lot to it because hopefully you watched the videos, you did those, the little mini quizzes and stuff. And so I'm going to put one up here. And I want everybody to write this down and try it. So I'll give you a couple of minutes to just solve this. Okay, so you need to solve, graph, and write your answer in interval notation. All right, let me give you a few minutes to try that. So remember, when you start solving these, you're going to solve them very similarly to how you would solve it if it was an equation, right? It's not until kind of the very end where you kind of use that inequality sign to work on things. But keep going with it. I'm going to just start working through it up here, but you can just keep going on yours. Okay, I'm going to have you guys look up here and see if, so far you have it to this point. And I want to encourage you, one thing that really makes a big difference when you're solving these is to remember that when you're solving inequalities, you always want to get your variable on the left-hand side. So I'm going to write that little note over here. And I say that because if you move your variable to the right side, you're actually going to be reading that inequality backwards, and that usually makes people write down their inequality statement wrong. So it's always a good idea to do that. Okay, so that's what I'm going to do here. So notice how I'm subtracting my x that's on the right side and moving it over to the left side. So then I get negative 2x minus 10 is greater than or equal to 12. Now I still need to add my 10 over. So negative 2x is greater than or equal to 22. And then I need to divide by a negative 2 here. Somebody remind us what happens when we divide by a negative.
You have to flip the inequality.
Yeah, okay, and I think that's probably one of the things that is missed most often on the test, because it's just remember, you know, like just taking your time enough to make sure you're not making that mistake. So and it's not just with dividing, but that's where we usually see it. Well, when we multiply, we're multiplying and dividing by a negative. Right, we've got to flip the inequality sign. Okay, and so that means that we'll come up with x is less than, maybe I'll change my color here, less than or equal to negative 11. Right, because I had to flip that sign the other way. And then I can draw out my little graph here. So if here's negative 11, we want the stuff equal to it, so it'll be a closed-in circle, and then all the stuff that's less than it. So all the stuff to the left, right? And so when I write that down in interval notation, remember, go from smallest to biggest. So I'm looking at this from left to right. So it's going clear out to negative infinity, and then it's going to stop at negative 11, and it includes it. Okay? And so that's what you get for your answer there. Questions on that one and how that went for you? Were you guys able to get to that answer? A couple of you said yes, hopefully. And if you're not getting that, please speak up. Okay? And I know that those of you that took 980, you'll see that, you know, some of this is review, right, from 980, but I know that there's some of you that didn't take 980, and so we're just giving you kind of a little preview of where we're going to be going here. Okay. All right, let's look at a homework question. Let me Okay, so here's a question similar to what you might see on your homework. And so I wanted to just kind of talk about these kind of application problems and how to deal with them, right? So there's a few things on here that are important to kind of make sure that you see, right? So we know that there's going to be a $75 cleanup fee, right? They charge $35 per guest, right, for food and drinks. And then there's only, right, they have a budget of $3,300 for this reception. And so they don't want to go over that. So notice that the question is, what is the maximum, right, number of guests that they can invite without going over the budget? All right, so we got to kind of break these things down that I underlined here and make sure you understand how to translate those into just like a mathematical statement, right? So taking English, translating it into math. So first of all, we see, and I'm going to write over here because I didn't really say this, but what we're trying to find is the number of guests. So I'm going to let x equal the number of guests, right? Because that's what I'm trying to find. So I always want to state, in here, what is my x representing? So I don't know how many guests I can invite, but I know they're going to charge $35 per guest. So part of my equation is going to say 35 times x. Right? And then it also tells me that no matter how many people come, I'm going to have a $75 cleaning fee. So this is a flat fee, right? That's not charged per person like the, like the meal is, right? That's charged per person, but there's just this flat fee of $75, right? It's going to be there. Okay, so now this is the part that I want you to tell me, right? We know that there is a budget of the $3,300, but I want you to just type in your chat in the chat box what symbol we're going to be using. Is it less than, greater than, less than or equal to, greater than or equal to? Don't hit enter quite yet. Type in what you think so everybody can have a chance to think about. All right, go ahead and hit enter. Let me see what you guys are thinking. Okay, so a lot of you are saying less than or equal to, right? You had a little bit of different ways. I like that little less than and then the equal sign behind it. That's awesome, right? But make sure that it's clear why it's a less than, right? Because we're saying the amount of money, right, that you're going to spend has to be less than or equal to the 3,300 because they said we don't want to go over that. And notice that word maximum was in there. And if you look back up here to when we wrote down these things, right, maximum was that less than or equal to symbol, right? So that could also help there to help you see that. And then from here, it's just solving it, like a normal inequality. But usually for most students, it's getting the correct inequality sign here, making sure that you're, putting your x next to the thing that is changing. Remember, that's like a rate, 35 per person. And, our slope is just a rate. So that's how we know that that's going to go there. All right, so then if we finish solving this, let's subtract the 75 over. Maybe some of you already have this done. All right, so when I subtract that, I get 3,225. Oops, that looks weird. And then I'll divide by 35. And so I get x is less than or equal to, and it should be something like 92.1428 blah, 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 blah. Right? But can you have a partial guest? Can I have 0.1428 of a guest I can invite? That would be really weird, right? So what would I write down for my answer here?
92.
Yeah. So we're not going to worry about the rest of that because, people, you need whole numbers here, whole number of people. So we'll just say less than or equal to 92, right? Because if you invite 93, that's going to be too many. It's going to go over it, right? So we have to stick with the 92. Okay, and that would be your answer. And make sure you're always remembering to put your little labels and stuff on, especially when, you're writing things on your weekly reviews and, especially on, tests and stuff like that too, right? And it just helps you to kind of think about what it is you just found there, okay? All right, well, that was all I was going to go over in 3.1, unless there were other questions on the homework that you wanted to look at. Does anybody have anything that you want to look at in 3.1? I'm going to take that as a no. Didn't hear anybody speak up, and nobody wrote anything in the chat. Okay, so hopefully 3.1 went pretty well for you guys. All right, so let's move on to 3.2 and talk a little bit about what we have going on there. All right, so 3.2, you're going to talk about union and intersection. And so first of all, let's define what an intersection is, what a union is. That will help us when we're trying to solve these, right? So intersection in math could be defined as elements that are common. Right, I'm going to kind of bold this or make that capital, right? So common to both sets. Or if you have 3 sets, then all 3 sets. Or if there's 4 sets, then all 4 sets, right? So that's what intersection is. And when you see the word and, so I'm going to put this kind of in quotes above it here. When you see the word and when you're solving equations, that is telling you that you want the intersection. You want the stuff that is common to both of them. And also there's a little symbol that looks like an upside down U that we use to denote intersection also. Okay, now the other, let's talk about union now. All right, so union could be defined of the set of all. Okay, now all is what I'm capitalizing here. Set of all elements that are in both sets. Right? So, or if there's 3 sets, all elements in all 3 sets. Okay? So, and union, when we see the word or, we should be thinking union, that we want, union is saying all, right? Everything there. And the little symbol for union is just a little U, right? Looks like a capital U on that. All right, so now that we have those defined, and hopefully you've got it kind of straight in your head which one's which, I think that the thing that is hardest for most students on this is just keeping these straight in your mind. What does it mean when it says and? What does it mean if it says or? Okay, and another thing, another way to maybe help you remember intersection, like think about 2 roads, right, that intersect with each other. Well, the part in which they overlap, right, the part they have in common, is the part that we call the intersection of those 2 roads. So sometimes for some students, just having that visual, you know, and being able to think, oh yeah, that really is part of both roads, right? If this was Redwood and this was like 47th, right? 4700 South or something. The part that those 2 intersect is just where those, you know, where they have both in common. So right in there. Okay. So sometimes just having something like that is helpful. All right. So let's do a couple of examples so we can kind of see the difference between these. So in all of these, you're going to solve, graph, and write your answer in interval notation. Now, I don't think there were any questions on the homework, and somebody correct me if I'm wrong, that asked for you to write it in inequality notation. I think all of the answers they want written in interval notation. Does anybody know and can confirm that? Did you write anything like, you know, x is greater than or equal to 3, you know, and, you know, I think you didn't have anything like this on it. I'm pretty sure everything needed to be written in interval notation.
Yeah, 5 does, I think.
Number 5 does what?
There was also like this big table we had to fill out.
That kind of went along with...
Like some of them would just have a line graph, and we would have to write in the inequality and interval notation.
Okay.
Or we would have interval notation, you had to graph and write the inequality.
Okay, that's good to know, yeah. So, because I was thinking that all of them asked for interval notation, but I forgot about that little chart that you had to fill in where it gave you, you know, like the graph, and then you had to write it in interval or in inequality notation. Okay, but most of them that you're just solving, graphing, you know, and stuff with, I think all of those you write in interval notation. So let's take a look at this one. If we have 2x plus 7 is less than negative 11, or, okay, so I'm going to take this, right, or the other equation is negative 3x minus 2 is less than or equal to 13. Okay, so go ahead and take a minute and solve both of those inequalities out. Sounds like everybody in 3.1, you can do those individually. So go ahead and do that right now. Okay, so notice on that second one, you needed to flip that inequality because you divided by a negative 3, right? And so make sure you remember to flip that inequality. And then if we graph it, right, so let me put my little graph over here. So here's negative 9, 8, 7, 6, 5, and 4, 3, 2, 1, and here's 0, right? I'm just putting in a few things there. It looks a little bit hard to tell which one is 5, but all right, so if we have negative 9, so we just want the stuff that is less than negative 9. So we're going to have an open circle there. Oops, let me use different colors. All right, so I'm trying to graph this on there. Right, I'll have an open circle at 9, and then it's going to be everything less than it, right? So that's everything to the left, so this way. And then the other one, let's do that green. All right, so that one at negative 5, there's an equal to part. And then everything greater than that. So that's going to be everything to the right. Okay. And also some people notice that, you know, this symbol, it kind of looks like an arrow pointing to the right. And that's the way you'll graph this. And on the orange one, right, x is less than, well, that symbol looks like an arrow pointing to the left, and so it's everything to the left there. Okay, now notice that we have an or statement. And remember, an or statement is the set of all elements. So that means we want everything that the orange has and everything that the green has, because both of those together, right, is going to tell us all elements in those. And so when I write that in interval notation, I'd have negative infinity to negative 9, parenthesis, because it has an open circle there, so it doesn't include it. Then I need to use the union symbol because there's stuff in between here that's not part of our solution, right? But then starting with and including negative 5, put a square bracket, negative 5, and then out to positive infinity. And so that would be our answer there. Okay, if you were to write it in, inequality, notation, right, it looks like this. You have, something kind of, they usually put it in these little squiggly brackets and stuff, but I'm not sure if on there it does, but it says x, and then it has this line such that x is less than negative 9, and then you have to make sure you use that or symbol, or, right, not the symbol, but the word, x is greater than or equal to negative 5. So when you write it in inequality notation, it's just written with those inequalities, but we have this part that's just saying any x that falls in this area, right, less than negative 9 or greater than or equal to negative 5. All right, what can I clarify there on that first one? All right, let's look at one with an and statement. So if we have negative 4 is less than or equal to 3x plus 5, and 2x minus 3 is less than 7. And again, I'm taking note of what my word is, right? Whether it's an and or an or. Okay, and then go ahead and solve these. Remember, on this first one, we want to bring that 3x over to the left-hand side. Otherwise, you're going to end up reading this backwards. And like I said, usually when that happens, people just tend to miss it a lot easier. So go ahead, and the first thing I would do is subtract that 3x over. And now I'll add the 4, and then divide by negative 3. And since I'm dividing by a negative, that's going to flip the sign. So that's going to give me x is greater than or equal to negative 3. And then I'll start this one by adding the 3 over, and then divide by 2. So x has to be greater than 5 on this one. So again, if I draw a little number line here. So x is greater than or equal to negative 3. So I'm going to have a closed-in circle there, and everything, everything greater than it. So everything to the right. And then on the other one, I have everything less than 5, so it doesn't include it, so there's an open circle there. And everything less than it is to the left. But since it's an and statement, right, I want to know what they have in common, or where the graphs overlap, right, is what I'm thinking of here. And that is right in between negative 3 and 5, right? And so if I wrote this in interval notation, right, I need to have a square bracket on my 3 because it has that equal to part. So square bracket, negative 3, and then up to 5, but not including 5. Okay. All right, still feeling okay? I hope you guys are going to speak up if you have anything here that you want to go over. All right, let's do one more and then I'm going to... Oh, yeah, go ahead.
I can't remember if it was 3.1 or 3.2. And I could
figure out, I could work out the answer, but not using an inequality. I didn't understand how to do it using an inequality.
So it was about a rental car, and there were two plans. Plan A was $30 a day, and then 15 cents
Okay.
per mile.
Yeah, I know which one you're talking about.
And then the second plan was just $50 a day, and it asked how many miles you have to drive for plan B to be the better option, basically.
Yeah. Okay. Let me see. Let me find that one. Okay. That one was on 3.1, I believe.
I think it was question 11.
Okay. Make just a little copy of that and bring it over so it's a little bit easier to see. All right. Let's see. Okay, so it's going to be, it's like this, right? All right.
Yeah.
So let's look at this one and I want you guys to kind of tell me what you think on this, how we might set it up. So a rental car company offers two plans for renting a car. Plan A is $30 a day and 18 cents a mile. And Plan B is $50 a day, but with unlimited mileage. All right, so for what range of miles will Plan B save you money, right? So you're trying to figure out, like, you know, there's going to be a part where, you know, if it's $50 a day, right, that's going to be more. So you have to be, you're going to be having to go a certain amount of miles before that really would become the better deal. And this is actually going to be kind of similar to what we're going to be talking about for our first project that we're going to be doing. And we're going to be comparing two different things with one another and kind of, you know, with this. So let's make sure that this is clear and how we're setting this up, right? So again, we're going to have two different equations this time, right, that we need to get set up on this. And then we're going to compare them and see which one is going to be better. So remember, so if we got $30 a day, oops, these, all right, so $30 per day and 18 cents per mile, or $50 a day with unlimited mileage, right? So you're only going to be paying $15 a day. So if I look at Plan A part, So I'm just going to kind of set these up here so you can kind of see what I mean. So plan A, we'd have $30 a day and 18 cents per mile. All right, so we're going to have, so each day, right, is that 30, but the mileage is what is changing on here. Maybe I should have written that down here too. So X is the number of miles. All right, because notice that's what it's asking you, right? What, you know, about the mileage. All right, so I'll have 18 times X, right? Because the number of miles times 0.18, let's write it as 18 cents, right? Times X, and then plus 30, right? And then plan B, whoops, plan B, is just going to be 50, right? So now what do I need to do with these in order to figure out, you know, this? Anybody have an idea?
I set the two equations to be equal to each other, so you find out whether they're equal.
Okay, so if we set them equal to each other, right, and then solve it for X, and then divide by the 0.18, what do we get here? So 20 divided by 0.18, so I got like 111.111111111, right? But I'll just kind of go to there, right? I mean, it keeps going and going and going. Okay, but so now, right, what is going to be our answer? So your answer, the mileage must be greater than how many miles?
111.
Yeah. And try and put that in. Like if we put 111, right, so let's put that in. So 0.18 times 111 plus 30, right? Let's see, you know, what happens there. All right, we get 49.98, right? And the other plan was $50, right? So does that seem right, that we'd have 111?
112.
Why do you think 112?
Well, actually, shouldn't it be like 111.12?
No,
I guess it would be 112.
no, because we'd want to round to the nearest mile. Yeah. So if we put in 112 then instead, right, then we're saying,
For my answer, I got
111.11, and that's the answer that it took.
yeah, I mean, I can see how, I guess it didn't say to round to the nearest mile or anything like that, right? But on this, you could see that here, right, so if we use plan A and we go 112 miles, we're going to be over $50, right? And so that's where it becomes the better deal. So I guess if they didn't say round to the nearest mile, then that 111.11 would work.
So what inequality symbol would we use with that? Other than just like the equal, would it be?
Well, you could, yeah, I was going to talk about that because it wouldn't really, I mean, are we saying that it would have to be less than 111 miles or greater than? And it should be greater than, right? Because it's asking, you know, your answer is the mileage must be greater than, whoops, why did I put less than? Sorry. Must be greater than, said greater than, it wrote less than, 111
Greater
miles.
than or equal to, or just greater than?
It would be greater than, not equal
Okay.
to. Yeah. So, yeah, so if it's not asking you to round to the nearest mile, which seems kind of weird, right? I mean, I think in real life they would just round things to the nearest mile, right? So 111 would still keep you under $50, where if you went to 112, that's when it's going to put you over $50. But people said that, you know, solved it. They just used that 111.111111 and they got it. So, hey, that was a good one to look at, right? Trying to compare two different things to one another can sometimes be a little bit tricky, you know, and try and figure out what is it they're asking here for really, right? All right, I want to do one more example here because we haven't done one like this. And this is a compound inequality statement. So again, my directions are to solve graph and write my answer in interval notation. Right? And so for this one, I'll have 2 is greater than negative 4x plus 2, which is greater than or equal than negative 6. So when you see something like this, right, where it's one statement, it's kind of taken two inequality statements and it's compacted it into just one statement, then this is always, always, always going to be an and statement. Because sometimes people get confused going, well, this doesn't say whether it's and or, but these are always and statements when they're written like this. Okay? And then to solve this, you're trying to get x by itself in the middle. Okay, and so that means I'm going to start by subtracting my 2 everywhere here. So that'll give me 0 is greater than negative 4x, which is greater than or equal to negative 8. And then I'm dividing by a negative here. So that means both of my inequality signs are going to flip. So 0 divided by anything is just 0. And then I'm going to have it's less than x, which is less than or equal to positive 2. All right, so this is saying x is between 0 and 2 and including 2.
So whatever you do to the middle, you have to do to the outsides too. Am I understanding that right?
That's exactly right. So that's why this one looks kind of weird, right? Because you're used to just having an equation where you're saying what I do to one side, I have to do to the other side. But on this one, since there's 3 different parts to it, right? And these are called tripartite, like statements and stuff. So whatever you're doing to the middle, you've got to make sure that you're doing to both of the outsides. That's exactly right.
So then since we're doing it, we're dividing by a negative, we're flipping both the sides.
Yes, exactly. Maybe I'll put these in different colors too, just to make it stand out that, right, that I flipped those inequalities because I divided by a negative. Okay. All right, I'm going to write down 2 more examples, but I want you guys to work on these 2 individually, and then I'm actually going to put you into some breakout rooms, and I want you to talk about what you came up with on these 2. Oops. Okay, so I want you to try this one. So write these down on your notebook and start working through them.